Welcome to this video on function notation. By the end of this video, you should be able to evaluate a function to find a particular value in the range, use an equation to evaluate a function, or use a graph to evaluate a function. We are going to complete the even exercises, and you will complete the odd exercises for practice. So function notation is when you have an equation that represents a function. It's instead of saying y equals, we're going to write f with a parenthesis and x. And then it's going to be the same from here out. This part guarantees what comes after is a function. And how you're going to say this part is read f of x. So f of x equals 4x minus 1. So the f of x is the output, and that just means the y value. And the x is called the input. It takes us back to when we were talking about function and not a function previously. Right, so in order to evaluate a function, function notation is used to tell you what you're going to be plugging in. So here we have an example, and this says if f of x equals 4x minus 1, find f of negative 7. F of negative 7. So do you see how there's an x there and now there's a negative 7? That says wherever there's an x, plug in negative 7. Okay, and then we're just going to solve it out. So we're wanting to know what f of negative 7 equals. So 4 times negative 7 is negative 28, minus 1 more. So f of negative 7 equals negative 29. Okay, so if there's a number in the x spot, that says plug that in for x. So let's try this. All right, so this says if we have f of x equals x plus 7, they want us to find f of 5. So we're looking for f of 5. The 5 is in the x spot. So that says wherever there's an x, plug in 5. So 5 plus 7. So f of 5 equals 12. Okay, so it's just telling you how to plug it in and where it goes. Now, they can get a little more complicated. Here we have g of x is 3x minus 8. But we want to find what g of negative 3 is. The letter doesn't matter, it's just like a different name. So we want g of negative 3. The negative 3 is in the x spot, so wherever the x is, we're going to plug in a negative 3. So then we have negative 9 minus 8. So g of negative 3 equals negative 17. Okay. All right, let's try it again. This one looks a little more complicated because it's got a fraction in there. We're wanting to find h of 9. The 9 is in the x spot. So instead of saying h of x, we have h of 9. So put it in the x spot. So 2 divided by 3 times 9. I'm going to put the 9 over a 1 so you can kind of see it as a fraction. And then minus 1 from that. So we want to multiply straight across, so we get 18 divided by 3 minus 1. Well, 18 divided by 3 is 6 minus 1, so h of 9 equals 5, because 6 minus 1 is 5. Okay? Sometimes we can plug it in more than once. Let me make this a little bit closer so you can see it a little bit easier. So if f of x equals x squared minus x, I want to know what f of negative 4 is. So the negative 4 is where the x goes. So everywhere there's an x, I'm going to plug in negative 4. I want you to be very careful. Do you notice every time I've been plugging in, I plug in parentheses. Minus negative 4. So negative 4 squared is 16, minus a negative 4 is plus 4. So f of negative 4 equals 20. All right, let's try a few more of these. Okay, I'm going to show you how to do this on Desmos now. We did a few by hand. Now I'm going to show you how to do this on Desmos. So take a second and pull out Desmos so you can try it also. All right, so we're going to do number 5 in Desmos. So I'm going to open up my Desmos window here, and I'm going to click into the first line, and I'm going to type it just like I see in number 5, which is f of x, and then it says equals negative x, and we want to square that. So I'm going to open up this keypad down on the bottom, and I'm going to click the squared. Now do you see how, so make sure your cursors come back down. So negative x squared plus 6x minus 4. Okay? So it gives us, this is called a parabola. We talked about those earlier. Now, I want to know specifically about f of 5. So I'm going to type in f of 5. And look, it says it equals negative 1. So on my paper, let's move our keyboard out of the way, f of 5 equals negative 1. Because the Desmos took the 5 and plugged it in for the x's and solved it for us. So let's try it again with number 6. So let me go back to Desmos so we can look at Desmos. And all we're going to do is we're going to just click out, use the X to get rid of what was already there. And let's type in number 6 where we say g of x equals negative 1 divided by 2 x. Now look at that. Do you see how the x is in the denominator and it gives you that weird graph? You don't want the x in the denominator. You want it next to the negative 1/2 x and then plus 9. So this is a line that they've given us here. But we specifically want to know about g of negative 8. So when I type in g of negative 8, it tells me the answer there is negative 13. So g of negative 8 equals negative 13. So let's have you stop the video and try number 7 and come back. All right, so using Desmos, you should have gotten f of negative 5 equals 21. I want to show you how to put this last one in. It's called an absolute value. So let's go over and open up Desmos. Okay, so number 8 starts g of x. So you got to make sure you have it typed in with the function notation. Now our absolute value, open up your keys, your keyboard if you haven't. Here's your absolute value right above the ABC. If you just click it, it gives you the 2 vertical bars. And we have x minus x, and then we're going to square it right here. And when I look back, that's everything that I needed to have. But I want to know specifically about g of negative 7. So remember, the Desmos is taking this number and plugging it into these x values for you. So this tells us that g of negative 7 is 56. G of negative 7 is 56. All right, let's try a couple of these on the back side. All right, so let's take a look. We're going to skip 9 and 10. We're going to look at 11 through 16. So now notice 11 says I have all my functions listed over here on the side. Take whatever f of x is, plug in negative 4, and when you get that answer, add 9. But let's take a look. Let's go find out what f of 4 equals. Okay, so let's go into Desmos, type in what number 11 is. So it says f, you want the f function. So f of x equals 8 minus 3x. Okay, we want to know specifically if we plugged in a 4 what we would get. So we're going to plug into a 4 into the x spot, and it tells us that f of 4 is negative 4. So f of 4 is negative 4. So we got our answer. Then it says add 9 to that. So what is negative 4 plus 9 is 5. So our answer to f of 4 plus 9 is 5. Okay. So we're going to try it again. Let's go with number 12 that says negative 2 times whatever g of 5 is. So let's find what g of negative 5 is. Right, so we're going to put in, so we want the g function this time because it says g of negative 5. So we type in g of x equals, and g of x is x squared, so x, come down to this a squared to square it, and then plus 2x. Plus 2x. G of x is x squared plus 2x. And we specifically want to know about g of negative 5. So we're going to let Desmos plug it in for us. And so for g of negative 5, we should get 15. So g of negative 5 equals 15. Well, looking back at the original problem, it says we want you to take negative 2 times whatever g of negative 5 is. So negative 2 times 15 equals negative 30. Okay. All right. So we're going to go a little bit more complicated here. We want to use g both times. One time we're going to plug in where g of 4, and one time we're going to have g of negative 1. So let's see, we want to know what g of 4 equals, and we want to know what g of negative 1 equals. So let's pull out our Desmos, exit out of what's already here, and put in, well, we could have probably left the g of x in. G of x equals x squared plus 2x. Okay, so that gave us this parabola. But really we just want to know what the 2 points are. So we want to know what g of 4 is, and we also want to know what g of negative 1 is. So that gives us both our answers. G of 4 is 24, and g of negative 1 is negative 1. Okay, g of 4 is 24, and g of negative 1 is negative 1. Now go back to what it asked. It said take whatever g of 4 is and add to it whatever g of negative 1 is. So this says 24 plus a negative 1, which is just 24 minus 1, which is 23. Okay, let's try that again. It takes just a second. Now, take a look at 14 here. 14 says, I want you to take 3 times whatever h of 2 is and subtract whatever f of 9 is. So this is really what it's telling us to do. 3 times h of 2. So whatever h2's number is, it's going to go in here and get multiplied by 3, minus whatever the f of 9 number, negative 9 number is. So we got to use 2 different functions here, the h1 and the f1, when we go into Desmos. So let's go into Desmos and see what we get. Okay, so we need, let's do the h1 first. So h of x equals negative 5 divided by 2. Okay, now remember, you want to come out from under the denominator to put your x in, otherwise you get those weird graphs. Okay, so negative 5/2 x minus 1, and we wanted to know specifically about h of 2. So I'm going to ask it for h of 2, and it tells us that h of 2 is negative 6. So I have written here h of 2 is negative 6, so that means negative 6 is going to go right here into this spot. Okay, now I need to know what this number is. We need the f function for that one. So go back to Desmos. Now, our f function is f of x equals 8 minus 3x. And we want to know about f of negative 9, which is 35. F of negative 5. So it just took negative 9 and plugged it in to our x value there for us. It just saves us a little bit of time. So f of negative 5 is 35. Negative 9 is 35. Okay, now look what it says. It says 3 times whatever h of 2 is. So 3 times negative 6 is negative 18. Minus whatever f of negative 9 is, which is 35. So negative 18 minus 35 equals negative 53. All right, those are probably as complicated as they're going to get. Now let's go ahead and take a look at 15 and 16. All right, so number 15 looks a little bit differently. Up until now, where the x was, we were putting a number, and we were saying that's what we're going to plug in. Number 15 says f of x, it still has x there, equals negative 13. That's the same as saying y equals negative 13. So really we're plugging in for the y spot, but we can still use Desmos. So here's what we're going to do. We're going to type this exactly how we see it. So let's bring up Desmos. And so we have f of x equals negative 13. Okay. And then we're using the f function because that's what it told us. And the f function is f of x equals 8 minus 3x. So I'm looking at that and I don't see anything. It didn't give me an answer, but here's what I want you to do. I want you to scroll out some on your graph. Right here, this is the line y equals negative 13. So really what we're looking for is where they cross. We already know about the negative 13, so what we are looking for is the x value there. And when we look at this point, we see that the x value where they cross is 7. So if this says if y equals negative 13, then x has to equal what number? X is going to equal 7 in this case. Okay, so they really took, instead of saying it's really, what we did is 13 equals 8 minus 3x, and we solved it. So let's look at 16. It's the same situation. See how there's no number in the x spot? They're saying h of x equals 39. So that's saying y equals 39 for the h function. So we're saying 39 equals negative 5 half x minus 1. Well, we're not doing these by hand. We can solve that by hand, but what we're doing is you're going to type this into Desmos. So let's pull up Desmos, empty out anything that's already there, and we have h of x equals 39. Okay. Then we're going to put the h function in. H of x also equals negative 5 half. Remember, 5 divided by 2. Come out from the denominator before you put your x in, otherwise you get the weird graphs. Minus 1. And I'm not seeing where they're crossing, so I got to scroll out. I'm going to keep scrolling. Oh, there, look at that. There it is right up there. There's that line. That says y equals 39, so it's going through the y-axis at 39. I want to know where they cross. So when y is 39, what's my x value there? It's negative 16. So I'm going to say x equals negative 16. Okay, so we could do these all by hand, but it's a lot easier to look at them graphically and get a better understanding of them. All right, so number 17 is a word problem. So we have anthropologists use the length of certain bones in the human skeleton to estimate the height of a living person. One of these bones is the femur. To estimate the height in centimeters of a female with a femur length of x, we use the function h of x equals 61.41 plus 2.32x. They want us to find h of 46. Now see, the 46 is in the x spot again. Okay, so let's pull up Desmos and we're going to put in the equation that they gave us. They said that h of x equals 61.41 plus 2.32x. That's what they gave us. You can see that's a line. Okay. We want to know specifically if the x value is 46. Okay. And it gives us the output of 168.13. Okay. So h of x, h of 46 equals 168.13. Okay, but what does that mean? So remember, we were talking about height in centimeters of a female with a femur length of a particular length. So this is a female with a femur length of, we put in 46 centimeters, has a height of 168.13 centimeters. So what we put in was the femur length, and what we got out was her estimated height. All right, our last two, we don't have any equations here. What we have are graphs, so we're going to have to read the graphs. Okay, so whenever we're finding, this is an x value, so we're saying I want to find the point if x is -3. I want to find the point if x is 1. I want to find the point if x is 0, or I want to find the point when x is 2, because all of those numbers were in the x spot. So let's try this first one. If x is -3, so from your origin, I'm going to go to where x is -3. 1, 2, 3. Then I need to travel to hit the graph. From where x is -3, I have to travel up if I want to hit the graph. So I want to know the name of that point. That point is -3, 2. Well, we already have the -3, so we're going to put 2. So if x is -3, y equals 2. Okay, let's try this again. If x is 1, that's right here where x is 1, I'd have to travel up if I'm going to hit the graph. The name of that point is 1, 2. So if x is 1, y equals 2. Okay. Here, if x is 0, that's right here at our origin, we're not moving left or right at all. To hit the graph, I can't go down. There's no graph down there for me to hit. I'd have to go up, and I'm going to hit it right here. The name of that point is 0, 1, 2, 3, 4, 5. So that says if f of 0, if my x value is 0, then my y value equals 5. One last one, if x is 2, here's where x is 2. This time I actually have to go down in order to hit the graph. I'll hit the graph right there. So the x value there is 2 and the y value is -1, 2, 3. So that's the name of the point, and the way we write it in function notation is if f of 2, if x is 2, then my y value equals -3. Okay, so let's try it without having to write the points this time. So f of -4, 1, 2, 3, 4, I have to go up to here to hit the graph. The name of that point is -4, 2. So if x is -4, then y equals 2. Let's try it again. If x is 0, well, we don't even have to move. That goes right through the origin, then y is 0, is what we're saying. We're saying if x is 2, 1, 2, in order to be on the graph, I'd have to go down, and I'll hit the graph right there. The name of that point is 2, -2. So if x is 2, that means my y value is negative 2. And one last one. If x is 5, 1, 2, 3, 4, 5, I have to go down to hit the graph. The name of that point is 5, negative 1. So if x is 5, then my y value is negative 1. Okay, I know that was a lot. Hopefully it was helpful. Let Desmos help you as much as you can. Let me know if you have any questions, and I'll see you in class first. Okay.